Okay, this is our last lesson of Unit 1. We're going to be talking about subsets of real numbers. So the easiest way kind of to describe all these different subsets is using this Venn diagram sort of deal here. So we're talking about real numbers today. Real numbers right now is every single number that you know. There are imaginary numbers. We're going to talk about those a little later. But right now, real numbers are everything. So all the numbers. If it's a number, it's real. For this Venn diagram, we're going to start at the most exclusive category here and work our way out. So first is the natural numbers. These are also called the counting numbers. And they're called the counting numbers because it's the numbers when you start counting, you start with 1, 2, 3, 4, 5, 6, and you go on from there. So 1, 2, 3, etc. So the natural numbers start from 1, and then it's just positive whole numbers from there. No 0, no negatives, just 1, 2, 3, and so on. Now when we move into whole numbers, it's all the natural numbers, because your natural numbers are still in the whole numbers box there. So the whole numbers are still all the natural numbers and 0. So the only difference between natural numbers and whole numbers is that whole numbers includes 0. So all the natural numbers and 0. So we start with 0, 1, 2, 3, etc. Okay, and then moving out is our integers. So integers include all the natural numbers, all the whole numbers, because those two boxes are still in the integer box. So it's all natural and whole numbers. And then we include the negative whole numbers. So we have like -3, -2, -1, 0, 1, 2, 3, and so on. So integers are positive and negative whole numbers. 0 is included there. Then we have rational numbers, which again, as we go out, rational includes all the integers, all the whole numbers, all the natural numbers. So natural numbers, whole numbers, integers, and now rational is when we include positive and negative fractions and decimals. Okay. So this would be like we add in like -3, -3 halves, -2, -1, -0.55 repeating, 0, 1, 1.23, 3/2. And so on. So positive and negative fractions, decimals, whole numbers, positive numbers, integers, 0, all that fun stuff. Basically, rational numbers is everything except irrational numbers. So a number can either be rational or irrational. It cannot be both. So a number can either be rational or irrational. It cannot be both. So the easiest way really is if a number is not rational, then it is irrational. And irrational numbers are when we have square roots of non-perfect squares or square roots that we can't easily evaluate. So it's like square root of 3, square root of 15, and so on. We can't evaluate those nicely. When you plug them into your calculator, you get an ugly decimal, and those decimals go on forever, and there's no pattern to it. With the decimals that are in rational numbers, those are all decimals that can be written as fractions. irrational numbers, their decimals cannot be written as fractions. So irrational numbers, square roots of non-perfect squares, square roots we don't know, and some of our common irrational numbers like pi. There's also an irrational number called e, which is Euler's number. So again, these are decimals that cannot be written as fractions. Okay, so a couple things to remember. First, all numbers at this point that we know are real. Make sure that when you're identifying numbers, everything is always simplified as much as possible before you start classifying. So what I mean by that is if we had a square root of 9, the square root of 9 is equal to 3, so you would treat that number as 3 when you're classifying. So 3 would be a natural number, it'd be a whole number, it'd be an integer, it'd be rational, and it'd be real. It'd be everything except irrational. And like we just saw with 3, numbers will usually be in more than one subset. So for example, if a number is whole, it's also, you just kind of start wherever the first group is, where it first appears, and then it's everything above it. So if it's whole, it's integer, rational, and everything is real. Okay, so let's do an example. Consider the following set of numbers, and we want to list which numbers are in the sets. So first we go through, make sure everything is simplified as much as possible. So -7 is good, -3/4 is good, 0 is good, .6 repeating is good, good. The square root of 81 is equal to 9. So we treat it as a 9. We'll still write it as square root of 81 when we're putting it in the sets, but we treat it as 9. So natural numbers are the counting numbers, so starting with 1, 2, 3, 4, 5, and so on. So 9 is a counting number, so square root of 81. And if you want to, since a number is a natural number, it's going to be everything else except irrational. Natural numbers are also whole, integers, rational, real. So right now, you can put that square root of 81 in every subset except for irrational. Okay, then, so square root of 81 is everywhere where it can be. So now let's move on to, and that's all our natural numbers. So let's move on to our whole numbers. Whole numbers are now where we add in 0. So 0 is here, and so 0 is a whole number, and it's everything above it. If a number is whole, it's also an integer, it's also rational, it's also real. So we can put that in these subsets, integer, rational, real. So now we're done with 0. Next comes integers. This is where we have our positive and negative whole numbers. So our only negative whole number that we have here is -7. And if a number is an integer, it's also rational, it's also real. So we're done with -7. Then we have our rational numbers, which are fractions and decimals that can be written as fractions. So in this case, it would be the -3/4, the 0.6 repeating, and the 7.3. So those are rational numbers. And if a number is rational, it's also real. So we're done with those. And then we're just left with our irrational numbers, which is square root of 5, a square root we don't know, and pi. And if a number is irrational, it's also real. Every single number is real. So right from the beginning, if you want to just copy all your numbers there into real, you can, because every number is going to be real. But then if we look between our rational numbers and our irrational numbers, there should be no overlap. Every number should be represented in between those two groups. There shouldn't be any left out because a number is either rational or real. Is either rational or irrational, but it cannot be both. So you cannot have a number that is written in both of those sets. All right. I want you guys to try example 2. This is where you're going to go through and you're going to list all the subsets that each of the following numbers falls into. So I'll do letter A with you. So letter A is -9. So the first time a -9 shows up in our subsets here is with integers when we have positive and negative whole numbers. So we'd write integers, and then it's also everything above it. So integers, rational, real. So for this, that's what you would write: integer, rational, and real. Okay, so I want you guys to go ahead and do the next 4. Write down all the sets that number falls into. Okay, now there's just going to be some quick check questions, self-assessment, and bring any questions you have to the Google Meet.